Okay, can you hear me? Cool. Hi, welcome. That's the spirit, I guess. You Polish people are not shy, I know that. Anyways, thanks for coming. My name is Dominick, and for those who know me, they probably know me because I've been working for many years on this thing called Identity Server, which is an authentication, an open source authentication framework that you can use in .NET. And it basically solves the who are you problem, right? It's all about identity, all about authentication. Now, inevitably, when you are done with that, you know who the user is. The next question you often have is like, and what is he allowed to do, right? And it turns out that this is actually a much harder problem to solve than authentication, because what I learned over the years is when you gather the requirements for an authentication system and you know all of the requirements, there's pretty much only one correct solution to the problem. Whereas with authorization, there are so many different approaches and techniques that might bring you to the same end result, but might work well or not so well for one application or the other. So many of our customers have asked us, like, can't you just do something like magic, right? So app.use authorization, job done. And the answer is no. So I think there is no silver bullet to the authorization problem. But at the same time, and that's like 1.5 years ago, I think. At the same time, we thought about why not create something reusable that people can use for authorization. And we basically turned that into a commercial product and also an open source library. So all I'm going to show you today is the open source library. All the concepts are in there. They are basically meant for you. If you like that approach, take it and modify it and do whatever you want with that. But before we started building that, Brock and I did some market research. So we asked our customers, like, how do you do authorization? And when you asked 10 developers, you got like 15 answers, right? Because they had different approaches over time, and maybe in different applications they implemented it differently. And we tried to find, just like in Identity Server, we tried to find the common ground here, right? So what is something that you can apply to most situations and then give the developers still enough freedom to put their stuff on top that is very specific to their own scenario. So in other words, what this talk is really about is what we've learned about that and why we made certain decisions that, and why we designed the library or the product the way we did. Okay, I hope that's interesting for you. Anyways, the only real important information in here, wow, that's big, is my email address or my Twitter handle if you want to, write me, and also the slides you can get from speakerdeck/least privilege. Cool. So yeah, that's the thing we've been working on. As I said, there's basically an open source version of that and a closed source version, and I'll show you later a little bit why we did it like that. Okay, so it turns out authorization is hard. I already mentioned that, There are many approaches out there. So when we started asking all the people, like, how do you do it, we got a couple of answers. And the 80-20 case, so to speak, was all about roles and permissions. Okay, so that is one of the most common approaches these days, how to do authorization in applications. Users have roles, and you assign permissions to roles, and then, depending on how fine-grained you want to do the authorization checks, you either, just do a role check. Is he a doctor, or does he also have the permission to perform surgery? Whatever, The very first customer we had was a hospital. That's why all my samples are kind of like in the hospital context. So that's what we found is the most common thing. What we also found is resource-based approaches, where you design your software as a resource tree, right? Think of let's say GitHub, yeah, where GitHub has organizations have repos, and in repos there are users which can do certain things, right? So you can think of that as a tree. GitHub defines the permissions and roles you can give, and the end user is actually giving them on resources, right? Closely related to that, which doesn't make your life easier, is multi-tenancy, right? So again, GitHub is a good example, right? There's only one GitHub, but many users, and depending on which user is logging in, these permissions apply, to different people and in different organizations and so on. So there's another, kind of dimension there as well. Access control lists, yeah, is something we found. Like Windows is doing it, where you attach entries to objects, right? Like a file on the file system, for example, and you have like inheritance going on, like you attach something to a folder that inherits down to the files. That is also something that people do. You have the widow problem with ACLs, right? Let's say a user leaves the company, now you have widowed orphaned, I should say, entries in your hierarchy, and that's like when you right-click a file in Windows and you just see a number and not a name anymore. That's because the person has left the company, right? And you have dead data, so to speak. Yeah. Another interesting problem is queries versus commands, right? So most authorization solutions I have for you and anybody else goes around commands, right? Is he allowed to do that? Is he, allowed to approve that document or whatever? Whereas when you're doing queries, right, it's often very specific what type of data structure you're using. Yeah, like with SQL, you might append a where clause that you only fill, you can filter the rows that come back from a database and so on. We haven't found a good solution, a generic solution to talk about, query authorization, to be honest. Yeah. Commands is much easier. So yeah, as I said, there are no standard solutions, and most developers we talked to, they basically created an authorization system which was very specific for the given application, right? It was so specific that they couldn't almost never reuse on the next project. Okay, that was our observation as well, and obviously, the coding of that framework typically only went that far that it just works well enough, right? Often that there were no UIs to configure it, or even an API, for example. Yeah, and I've seen many applications out there where you change the authorization rules with SQL Server Management Studio. That's another thing, and the reason I think why this is interesting is that there is a very, very blurry line between what is authorization and what is actually business rules. Yeah, and the more you're building a system that is all about business rules, the more it is specific to that one application you're building it for, and then it's not really reusable anymore. Yeah, whereas when you stick to simple authorization constructs, for example, roles, permissions, and resources, then there's a much higher chance that you can take the same code and move it to the next project, and you have to, find your line between, okay, that's authorization, and that is business logic, yeah, and that is not easy, yeah. Has anyone ever heard of XAML, the extensible access control markup language? Anyone? Two? Okay, that is free. Excellent. Do you like it? Say no or yes, please. Thank you. Yes. So, 10 years ago, there was like, by the times where everything was start with an X, basically, yeah, and it was angle brackets, right? People created something that should be like the one-size-fits-all authorization solution, and it was you basically defined your rules in XML. Yeah, so, and it was a big enterprise thing, right? And the way this typically worked was your application had to export some sort of context. yeah, like what are the details of what's going on right now, send that context to some server. Then the server had to parse that context and then apply an XML rule, and you got back true or false. Okay? And in XML, you could do anything, right? From simple checks up to super deep business-related or specific stuff. I went to their documentation, and that's the simplest example they had. Okay? And that is just basically determining if a user can log in between 9 and 5. Okay? That's basically what this is doing. Yeah, it's madness. Yeah. I recently showed that to someone and said, hey, we have a new version of that. You can now do it in JSON as well. I said, okay. Is that actually any better? Yeah. So the reason why only 3 people raised their hands and they said no, they don't like it, is it was massively complex. Okay? And many people realized, wow, this here can be done in 1 line of C#. Right? And you don't have to have a network round trip for that. Yeah? So, that's what I mean with if you're going 1 step too far with the authorization system, you are basically having too much ceremony around it, yeah? Like exporting context, passing context, returning stuff, that it's not worth it anymore. Someone will take a shortcut and says, like, because I can do this in 1 line, it's 1 if statement, okay? Why would I use that external system? And I think that was a design decision or something that drove us. Make it easy, because as soon as you end up with something like this, no one will use it. So yeah, which basically led us to the following view of the world. Yeah, different levels of authorization, are implemented best using different types of abstractions. Yeah? So there is, for example, the global access problem, right? Is this user allowed to use an application, or is this client allowed to call an API? And that is often pretty easily done by using global policies in your code, or maybe, access tokens, like, is a client allowed to call an API? It's pretty much easily handled in your token server, where you have an access rule, which client is allowed to access which APIs. Job done. Once you are inside the code or the API, access to a feature, like is he allowed to do this or is he allowed to do that, that is actually really, really nice and efficient and well understood, being done with roles and permissions. Okay? Once you are inside the feature, I think that's not authorization anymore. That is business logic, right? And if you're looking at that, typically you are kind of like building your core business, domain knowledge here. So that's why I say I don't think a standard framework for authorization can handle that. You have to build something that is specific to your application from this point on. But all the other stages before, I think you can easily do that with something more generic. Okay. So does anyone remember this? Windows SEMAN, not SMAN, as some people call it. It's SEMAN, the Authorization Manager. And that was a brilliant idea. Many companies use Active Directory, for example, for their authorization. Yeah, in AD, you can be member of groups, and then in your code, you check, like, is he member of the sales group, so he's allowed to open the sales application or the marketing application whatsoever. Guess what? The inventors of Active Directory never thought that they should use AD for application authorization. It was built for managing access to printers and file shares and these kind of things, right? But, people are creative, and they said, oh, we have this thing called AD, and you can put users into groups, so why not use that as an application authorization mechanism? With all the problems, right? A, groups are pretty limited. Once it gets a little bit deeper, you need to build something in addition anyways, but also typically only one person is allowed to create groups in AD, right? It's the admin, the domain admin. So when you want a new group, well, you better be good friends with this guy. So what Microsoft did, and that was a brilliant idea, it silently died because no one cared, actually, is building something which sits on top of the identity system, okay? AD is an identity system, and something sits on top that now you can import the identities from the identity system and make application-specific authorization rules. Yeah, so what they had in SEMAN was groups, yeah, which are basically roles, yeah, and then you can assign to groups which tasks can they fulfill in the application, and that's pretty much like permissions, right? And you could even go a little bit deeper and split up tasks into operations if that's what you wanted, yeah. But the point was, this was independent from Active Directory. This was something that the application basically, this had an API. The application talked to this API, loaded that application definition, and then said, okay, here's the user, and he's trying to do this. Is he allowed to do that, yes or no? Okay. The reason this died is, well, it was a COM API, and nobody really cared to update that to something newer, like more modern, right? It's actually still there. When you type in seman.msc on your Windows machine, this window will pop up, but you can only open definitions. You can't create new ones anymore because it's basically not supported anymore. No? So I wrote blog posts about this in 2005, how to write custom authorized attributes for ASP.NET and talk to this thing. So I was always inspired by this idea, and what I really liked about it was the clean separation between the identity system and the authorization system, because they have different functions, right? And the other thing is that AD, you only have one AD, right? But here you could create application-specific policies, which is different, yeah? So really, my motivation for writing this policy server thing was, let's take that and, transport it to the modern world, yeah? How would that look like? Well, in the modern world, first of all, everything is based on token-based authentication, yeah? And that means everything is based on claims-based identity. At least in my modern world, I know that this is not reality everywhere, but, that's what we want to build. The other thing is that the identity provider shouldn't matter, okay? In SEMAN, this was hardwired to Active Directory. We wanted to build something that can work with any identity system out there. Might be Active Directory, might be, whatever, Google, whatever. Yeah, because it's based on claims and not some specific technology. So now in these more modern style applications, you have many places where you need the authorization data. Yeah? And that maybe is also a little bit different to how it worked with in 12 years ago. So the question is now, let's say we have this thing that maps users to roles and permissions and applications and so on. How do we distribute that data to the applications that need it? Yeah? And there are a couple of opinions out there. A very popular opinion is putting it into the security token, right? So now we have a token system, yeah? And it issues tokens for users, so why not put all the authorization rules into this token? Because, these tokens get sent to the various places in your application. Why not piggyback on that mechanism and send that additional data, yeah? There are many popular products out there that do that. For example, Azure Active Directory, some others, Keycloak, for example. I personally don't like that, yeah? And the reason for that is a couple of things. First of all, like in OpenID Connect, an identity token, well, the name says it already, right? It's about identity, not about permissions, yeah? That's one thing. Tokens should transport authentication metadata, like who is the user and how did he authenticate and when did he authenticate and how long will he be allowed in the system and stuff like that. It should contain identity information. But what is this? Yeah, that's clearly authorization data. Permissions, yeah, like the delete data permission, yeah, the manage customers permission. Now, there's one problem here. You see that in OAuth, there's this claim, or in JSON Web Tokens, I should say, there's this claim called audience, right? An audience means at which APIs can this token be used? Yeah. So back in the WS star times, you basically had one token for each service you're talking to, which meant you made many round trips, so the token server had to deal with many tokens. In OAuth, that is typically not the way it's working. you are getting one token, and that can be used at various APIs. Okay? So we can use this thing at API 1 and API 2. What if, it turns out that this user is only allowed to delete data in API 1, but not in API 2? Okay? So these claims become ambiguous. And then, I met smart people saying, yeah, we're going to prefix them. API 1.delete data and API 2.manage customers. Yeah? I don't think that feels right. Yeah, you're basically coupling two things together: authentication and authorization, and they are two different functions in our system. Yeah. The other thing is this might work well as long as the system is not growing more than you planned first. Again, what happens if you add new APIs to it, and suddenly again these things become ambiguous, and you have to be very careful how you pass that data. The other thing is tokens. You typically only get tokens at authentication time, right? Meaning, if you want to update that information inside the token, you have to re-authenticate. Windows has this exact problem where, like let's say an admin puts you into a Windows group, you have to log off and log on again to make that group effective for you, right? Because, well, they store the group memberships in the token. So that's another thing. Certain products now recommend make the token lifetime really short, that when you refresh those tokens in the background, you can update those permissions as well. Again, I think you're coupling two things together which are not really coupled together, right? One is identity, the other one is authorization. And the last thing, and that is a funny story actually, these tokens get bigger, right? The more and more permissions you stuff into them, these tokens get bigger. So I had a customer recently, well, actually just last week, he called me and said like, hey, our identity server is broken. It just, it doesn't work anymore. And it turns out in ASP.NET Core, they have a feature when they receive an external token, let's say from Azure AD, they just copy the contents into a cookie temporarily so you can, work on that content. So now in Azure AD, they turned on a new feature called group memberships. And guess what? Microsoft now puts up to 150 groups into their tokens they issue to client applications. So now someone turned on this thing in AD, the token came to ASP.NET Core, ASP.NET Core tried to copy the contents of the token to the cookie. Guess what happened? It blew up, right? The cookie became too big. Yeah, and they're overflowing those cookies, but in the end, I think they exceeded more than 32 kilobytes. Yeah, again, I don't think, and that's my personal opinion, I don't think security tokens are the best transport mechanism for authorization data. Okay, what about roles? That's always a good question, yeah? So roles is a bit of a gray area, I think. In my mind, there are two types of roles. One is called an identity role, and one is called more like an application role, I would say. Yeah. So in this example here, in my mind, the doctor is more like an identity role, right? In this customer system, regardless where this guy logs in, he's always a doctor. There's no situation where this guy is a nurse. Yeah. So that is something universal. Whereas approver depends on which application he's using, right? So he might be able to approve the treatment plan in the oncology department, but not somewhere else, okay? So again, I think you should draw a line here between identity and authorization, and the way I remember that is, identity is something universal, okay? So wherever, regardless how you log in and where you log in, you will always be the same person. But what you are allowed to do is very context specific and might be dealt differently with depending on what you are doing. So, like on your passport, for example, there is a claim date of birth, right? That's identity. There is no claim saying you are allowed to drink alcohol, because that rule changes depending on where you try to drink alcohol, right? So in Germany, it's 16, depending on what you're drinking, and the States, it's 21. Someone recently said in Ireland, it's 8. That might be true, I don't know. My point is, this wouldn't be a good claim, okay? Date of birth is a good claim, and you can derive the authorization from that claim instead of putting the, that authorization data on the passport. Okay, so if you take one thing away from this, that is what my thinking is. Identity is not permissions. What I rather think is that identity should be the input to your permission system. Okay? As I said, with the bar scenario, right? The passport is an input to the barkeeper, so to speak, and the output will be yes or no. Yeah? And that's how I like to see it as well. You take the identity of a user, you feed it into a system that is aware of context, and you get back authorization data. And that means that in my mind, there is a separate function called a policy provider. And you can name it whatever you want, but the point is, it's something that deals with authorization policies, and it's a logically separate thing from the identity provider. Okay? And again, they could be totally different things. So basically, the way I think this works, or well, works for us at least, is, the user logs onto the system, he authenticates with the identity provider, he gets back a token that represents the identity of the user, and now the client has a client library, so to speak, that extracts the identity from the token, sends it to the policy provider, saying, hey, I'm the front end, here's the user, give me the front end related permissions. Now, he calls APIs, sends that token to the APIs have client libraries that extract the identity and talk to the policy provider saying, hey, I'm API 1 or patient API, here's this user, what is he allowed to do? Okay? This might look really chatty, but obviously client libraries can do a lot of things for you with caching and making sure you're not overdoing it with network round trips. Okay? And if you then put a nice admin UI on top of that, you make your business, your product owners really happy, right? Because now a non-developer can go somewhere and change the permissions of users without you having to recompile your code or use SQL Server Management Studio. Okay, so in other words, the thing we build basically looks in a nutshell like this. Yeah, it's basically two APIs, a management API and a client API. The management API allows you to define all these role mappings and so on. And the client API is the thing that talks to client applications. There's a client library that calls the client API in a certain application context, passes in the identity, and gets back authorization information. Yeah, I think that's not rocket science, but it actually, because it is not that complicated, yeah, it's proven to, it has worked for a couple of customers, and we didn't have to, change it because they also found a good boundary between authorization and business rules. Okay, so that's about how we implemented it. The second part of the talk is more like, now you have something like this, how could you integrate it into your client applications? I'm using ASP.NET Core as an example, just because that's what I mainly do these days, and also because they have a pretty nice new authorization client API built in that you can use for your purposes. Okay, let me quickly switch to code. Okay, so basically what we're having here is let's show you the app first. Yeah, it's a sample app. We can log in, and we basically have three types of users. One is Alice is a doctor, Bob is a nurse, and everyone else is a patient. Okay, and when you look at the code, you see basically it's all hacked up, and that's my point. The identity system doesn't matter. Yeah, it could be something as simple as that. It could be Active Directory. It could be something really complicated. The point is, it's all based on claims. Okay. So you see, Alice has a subject ID of 1, and her name is Alice. Bob is subject 11, and everyone else is a patient because he's very sick. Okay? So, in other words, when I log in here, let's say I'm Alice. Okay? All I'm doing here now is printing out the claims that Alice has, and again, the source of these claims is totally arbitrary. Now, at the same time, we have a policy. So let's have a look at the policy. And in this simple example here, it's just in a JSON file. Yeah. So you see, basically, here's our mapping. doctors, so for this example, we support two types of mappings. One is more like an explicit mapping, where you say like user 1 and user 2, they are doctors. Or you are mapping identity roles coming from the identity system to application roles. Okay? So in that case, if this user has an identity role from the identity provider called surgeon, he becomes a doctor in the application. Okay? And you see, for example, for the patients, we didn't do any upfront mapping at all, but we look at a role called customer. If they are in the customer role, well, they must be patients, right? Of course, this is all very oversimplified, but you get the idea. And then you see in the second part here, you can now map permissions to roles, okay? Who can see the patients, who can perform the surgery, who can prescribe medication, and who can request medication, okay? So there's a simple client library here that basically, acts as your programming interface, if you like. So that's here. So we're going to add that to the DI container. And basically, this in this sample, as I said, reads from the config file. So on our account controller, or home controller rather, I can now, enable this as a dependency. Like this, and also pass it in here. And then on our view here, what we actually do is get rid of that, call our client library, and then whatever turns out gets passed to the view. So again, you see here that the evaluate async method, it passes in a user object, and in essence, what it really does is it passes in claims. Okay, so there's just a convenience method here, but you can pass in a claims principal. This reads the claims and then sends it to the evaluation process. You could make up those claims on the fly, right? Like say, I have a user which has these properties. Now tell me what he's allowed to do. Okay. So when we change that code now, we should see that now we also see the results, right? So I logged in as Alice, and the permission, the policy says. She's a doctor, and she can see, patients and perform surgery and so on. So if I would remove Alice, for example, from here, right? So she's no doctor anymore, and refresh, these things would go away. No? Let's revert that. Okay, so that's easy, right? You basically pass in the claims of the incoming user, and depending on the definition, you get back the roles and permissions. And if you're writing a new application from scratch, maybe that's exactly what you want, a really nice and easy to use client library that you can use and wrap in your own APIs. One thing I learned when doing the authorization research is there are many different styles out there, there are many different opinions out there, and there's a lot of existing code. Yeah. So sometimes telling people, hey, we have this client library, want to just use it, doesn't work except for greenfield scenarios. Yeah. What many people already do is they have an existing investment into claims-based identity. Okay, so they already have things like they write code against claims principle, for example, and they use claims for roles and things like that. So another way to integrate such a policy system is by a technique called claims transformation. And the idea of claims transformation is that you have a middleware running in your pipeline that when the request comes in and the user is authenticated, you actually call the policy system automatically based on the incoming request. And whatever comes back, you augment the claims principle so that now, without having to change your APIs, you get new claims called role and permission. Okay? Let me show you that as well. So in my startup here, there is a middleware. And as I said, all this is doing is it basically uses the client library to call the policy evaluation automatically. Okay? So, and what will happen now when I refresh the pages, there's now a second identity. You know, in .NET, claims principal can act as a container for multiple identities. And that's the feature we're using here. So the first identity is called password, and that's the thing that got produced by the login page. Okay? The second identity is called policy server middleware, and that's the identity produced by our middleware. The nice thing about that is now when you're doing the APIs against claims principal, they iterate over all identities internally. So you don't need to know that there's a second identity. All your client code will now see roles and permissions, okay, without having to do any changes to your code. So let's say you are having existing investments in something like this, right? Where you say role equals nurse, yeah, and that's what our developers are using, and we don't want them to learn something new, right? You can now make this happen by just injecting those claims dynamically from the new policy system, okay? So I don't know, what is this doing? Nurses only, whatever a nurses only action is. Let's try it. I'm a doctor, I'm access denied, that's good, right? So if I log in as a nurse, Bob, I should now do a nurses only action, okay? So, to be honest, I'm not really a big fan of this old authorize attribute the way it is, right? Because it's all tightly coupling together your authorization rules and your business code and so on. And you know, if you only have a couple of controllers and you have these authorized things there, that might be doable, right? But if you have like a big API or a big application with many controllers, then this is a really maintenance nightmare, right? And if the rules are changing, you have to go to every single controller and make sure you're changing these things the right way. Okay, so yeah, we complained to Microsoft for a long time that the authorize attribute is not really useful because it pushes you to bad style, if you like, and they finally listened to us when they had the chance to make breaking changes. And starting with ASP.NET Core, there's a brand new authorization library built into it. And funnily enough, one of the first questions I always get is, I like this library. Can I use it with the old MVC and the old Web API? And it turns out you can. There's a guy, David Parks 8, he backported the whole thing to Owin so that you can also, if you like that style of programming, use that with older APIs and web apps, for example. Yeah. What is the main feature of this new library? Well, they decouple, they decouple the authorization logic from the business logic by allowing you to define these things in two different places. It's extensible, so you can basically do your own higher level abstractions on top of that. And one of my favorite features is it's testable now, right? I mean, have you ever tried to automatically test the existence of authorized attributes and that they have the right value and they are in the right place? Things like that. It's a nightmare. With this new model, you can actually write unit tests against your authorization logic and can prove it's working. And if somebody is changing it, you can prove he broke it. Okay? So the way this works is basically you are defining these policies in your code and give them names. Okay, for example, there's a policy called perform surgery, and then you can add an arbitrary, complex, or simple list of so-called requirements to it. Yeah. So, for example, in this scenario here, the only what it basically means is you need to be authenticated and you need to have a permission called perform surgery. Okay, and then you can put that policy wherever you want in your code, and it will always run this centrally defined thing. So if, for whatever reason, the logic changes to determine who is allowed to perform surgery, you just have to change it in one place, and all of your controllers will, get that new behavior automatically. And with automatically, I mean by recompiling. So let's put that somewhere. Let's put it here. Whatever. Yeah. So now I have a policy called perform surgery. So now I can go to my home controller, and there's a method here that does exactly that. it calls this method called, or calls this policy called perform surgery. And if you're allowed, well, you can do, you can perform a surgery, right? That makes sense. So in other words, I'm a nurse, right? So perform surgery, that shouldn't work. Good. But if I'm a doctor, I should be able to perform a surgery. Excellent. Okay? So this whole system is extensible, and I'll show you an example of the extensibility in a second. The only thing that bothers me now is, right, for many times, all you want is a one-to-one mapping between the policy and the actual permission. Yeah, so let's say you have 1,000 permissions in your project. Do you really want to create 1,000 policies that basically only say, like, does he have a permission of this? Does he have a permission of that? So if your policies are that simple, there's another nice thing they build into these ASP.NET Core policies, is that you can create them dynamically at runtime. So the idea is this. There's a feature called a policy provider. And what this allows you to do is take over how ASP.NET resolves the policy based on the name. Okay? So basically what we did is, do I have a code sample here? No, but I can show it to you in a second. Basically what we did is now is we plug in our own policy provider, and what this will do is it will first look at, is there a statically defined policy with that name? And if not, it will synthesize a new policy which with exactly that behavior here, it will check for the permission of the same name. Okay, in other words, you get them now without having to write any code. Okay, so let's do this. I'll remove my static policy again, okay? And by doing that, you will see that my code will immediately break. Yeah? Because it says, hey, you are checking for a thing called perform surgery, but this doesn't exist anymore, so something is wrong, okay? But now what I can do in my startup, I can now enable this dynamic policy feature, yeah, just by wiring up in the DI container. And just by virtue of doing that, now my application should work again, okay? And now you don't have to define any policies anymore as long as you do a simple mapping from policy name to permission. If you do more complex things, like check several things, then you know these still take precedence over the dynamic created ones. So again, all that source code for doing that is in the sample here. When you scroll up or down, it's somewhere here. Yeah. So you can use that, and I can show you the URL again for the repo. Okay, what else can we do with this new ASP.NET Core thing? Custom requirements, okay? So let's say you have requirements in policies which are more complicated than just mapping a claim to, you know, a permission claim, for example. So let's say, for example, when somebody gives medication to a patient, yeah, you want to check, like, is this person qualified for the type of medication and for the amount of medication it's giving, okay? And be careful. We are already very, very close to the line of, is this business logic now or authorization, right? But yeah, let's just, for the sake of the example, do that, yeah? So what you would do is basically you require, you define a class called medication requirement. You derive from authorization requirement. Again, that's all Microsoft code, yeah? And then basically you write a handler that whenever a policy gets invoked that has this medication requirement in it, it will execute the requirement handler. And as you can see, this is a very realistic policy that I'm implementing here, right? So first of all, the first takeaway is now inside my custom requirement, I again use my client library to talk to my policy system, right? So it's not all or nothing. You just use this or that. You can combine these things together, right? On one hand, I want to get policy. On the other hand, I have custom logic living in my application. So I'm first checking, like, does this user have the prescribed medication permission, right? And if the amount is smaller than 10, it's allowed, right? If the amount is higher than 10, it must be a doctor in addition. Or it's a placebo, and then everybody can do it, okay? Very realistic. Anyways, how would that work? basically, you encapsulate that logic into this requirement handler. Yeah, it's here, the medication requirement handler. That's the code you've just seen. Okay, and once that is wired up in the DI system, I can basically, somewhere is my prescribed medication method. Yeah, let's do that. Okay, so here basically I new up a medication requirement object, pass in the amount and the name, and then I basically say, okay, for this current user, check if this requirement is fulfilled, and if yes, allow it, otherwise don't. Okay, so again, who are we? Well, we need to recompile, I think. Yeah, I'm a doctor. Well, let's log out and become a nurse. That's easier to show. Right, so I'm a nurse now. So basically, I want to prescribe 10 milligram aspirin. Ooh. Oh, yes. Hold on. There's something missing. I need another dependency here. Like this. Okay. Come on, recompile. Yeah, here we are. Okay, again, I'm a nurse. I want to prescribe 10 milligram aspirin. That's not allowed, right, because it's 10, and only doctors are allowed to prescribe 10. But if I want to prescribe 50 milligram placebo, this is also allowed. What? What? No, I'm always denied. That's weird. Okay, somewhere's a bug, but you get the idea, okay? Let's log in as a doctor again. Let's see. Huh. Okay, I'm doing something wrong. Anyways, that's weird. Okay, whatever. Okay, so these are the things you can do with this new authorization API in ASP.NET Core, and again, as I said, you can use it also in older applications as well. The last thing I want to make you aware of is you can also have global policies in ASP.NET Core. So basically, policies that apply to every request coming into the system. And they work exactly the same. You could use custom requirements here and so on and so forth. That's just, automatically executed for you. Okay, so as a summary, the main 3 takeaways we had while building this is decide on how granular you want to go, right? Make that decision. It's a design decision, really. Yeah. Do you want to basically build an authorization system or use one and then combine that with the business logic, or do you want to build something that bakes them together with the consequence that you will never be able to reuse the authorization parts again because they are now completely application specific. Yeah. Think again. Keep this picture in mind. Yeah, like how granular do you want to authorize, and think about which approach we're going to take depending on how we do it. The delivery mechanism. How do you transmit the policies to your applications? Basically, there's one school of thought is at login time, or you basically collect all the stuff at login time and shove it to the applications. That's typically done with a token. Or the one I prefer is on demand using a good old API call from your clients to the policy system. And the client API, so what you typically end up with is for the more simple cases, you can use the plain ASP.NET Core authorization system. But for most cases, what they do is they combine together the policy system, the policy server, like the evaluation engine, and wrap that in some sort of custom API or custom code. Okay, here are some resources, again, if you want to read more about that. And I think we have a little bit more time for questions now. And also, when, like a first come, first serve, we have some stickers, but not enough, sorry. Thank you.